What we've learned through plant analysis and plant sap analysis is that we definitely believe that testing inside the plant and inside the cells of the plant is of extreme importance for diagnostic capabilities. It's well understood that soil analysis is very, you know, productive and helpful in terms of agronomic unpacking of large scale ag systems. But the focus over the years has been a lot more on soil than on plant analysis. People will analyze soil multiple times during a season. Sometimes maybe they'll do water, and maybe they'll do one plant analysis per season. But by testing the plants, and not just the plant's leaves, but actually, in certain cases, the bark, the buds, stems, petioles, a lot of different organs of the plant, there's new information that can be gathered and new techniques and inspiration for management strategies that can be gained. This is what we refer to by the best of crop science and technology. There's a number of different strategies out there for application, right? So drones, other forms of robotics and AI, and there's a lot of new technology on the application side coming in. There's a lot of imaging technology coming in. There's a lot of new technology related to microbials and plant stimulants and plant mineral ferments and so on and so forth. These can enhance the biotic growth capabilities of the plant by decreasing abiotic stress. And when used in successful coordination with one another, there's a long-term strategy that can snowball in a positive manner. I frequently talk to growers across the country and across the world that have utilized these techniques to cut their crop inputs, whether it's fertilizers or pesticides, back anywhere from 20 to 60 to 70%, maybe more in certain cases. And this is what happens when you unpack successful precision analysis with other operational toolkits, i.e. imaging, application, microbial, mineral, biological, et cetera, et cetera. But none of this really matters if you don't work within a crop production budget. And every different crop has a variety of ranges of crop production, whether it's organic or whether it's low-cost conventional, or whether it's somewhere in the middle for a reasonably well-developed market. At the end of the day, everybody has to make money. Everyone has to turn a profit for whatever reason that might be. If they're not turning a profit, they're not going to be in business for very long. And crop production budgets do need to be adhered to throughout the regenerative process. This is really key, because if that's not a fundamental principle when getting off on the right foot, you're going to be starting into a long-term downward spiral of this isn't going to work, and that's not going to work, and this is not going to work. And then by the time all of those things don't work, you're going to be right back to where you started with conventional programs and so on. And so the goal of this webinar is to teach you the step-by-step way to unpack these systems using analysis, technology, applications, and your own management strategy, so that you can do this in a successful way, regardless of crop, regardless of growing situation, regardless of the type of crop that you're trying to go and achieve, and where you're actually starting from. They can all be, achieved through this method. And so the use of cutting-edge lab protocols is fundamental, right? We can't stop and eliminate one from another. A lot of folks will come to us and they'll say, can we use another lab test, or can we get started without one, or can you make an appropriate crop recommendation without precision data? And the answer is, generally speaking, no. We can do a little bit, but the results vastly differ once we're using precision data. And we're not the only lab that's capable of this. There's a lot of other labs out there that have really good information. and are capable of providing strong precision recommendations to you. That said, if the lab isn't providing you with enough recommendations and strong crop performance to get you to where you want to be agronomically, then I would suggest you maybe explore other options for labs. And what do I mean by goals agronomically? So some people want to transition to organic, but have never been capable of doing it because they don't know how. You have to use the right lab techniques like we talked about throughout the webinar series, right? So different soil analysis methods, different extraction protocols, different inputs and so on, and matching those up to meet one another. Additionally, if you're not meeting your crop yield goals, then you should also consider looking for another laboratory or another agronomist to work with or something. And then last but not least, if you're not meeting just overall economic goals, right? So if your crop production budget keeps rising, but your profit margin starts narrowing, right? Then that's another signal. And the good news is that once you start to get really good results, you can find your footing and then continue to build on that success. But in order to assure that you're actually getting good lab data, the one of the keys that we've found is implementing comparison sampling. And so this is a common theme that we've talked about throughout the series: sampling the new leaf and the old leaf of the plant, sampling the weak areas of the field and the strong areas of the field, sampling the source water and the field water on an irrigation system, sampling the different soils extraction methods and protocols, using everything from strong acids to weak acids to water. Looking at all of those in coordination, there's going to be insights to be gained individually, but when you look at them in comparison as a reference, this adds much more layers of detail and can speed up your reference. So in other words, if you go out and you sample the new leaf and the old leaf of a plant, and you get a good data set, but if part of that field is not performing properly, then you go out and you sample the new leaf and the old leaf of the underperforming part of the field as well. So now and then you have both of those data sets to compare to one another. So now you have a much more rich and robust data set to compare with and understand how your plants are behaving and why they're behaving so. For instance, say you take an orchard or a field of grapes or berries or something like that, and part of the field says, okay, we're slightly low on phosphorus, we've got a good amount of calcium, but our micronutrients could use some fine tuning, our nitrogen's good, and our potassium is no problem, right? But then you go over to the weak part of that same field and you sample that and then compare the new leaf and the old leaf and look at that data set. Well, all of a sudden, then this one has a sulfur excess, an aluminum excess, and what those two excesses are doing, perhaps, is impinging upon the phosphorus deficiency that's minor over here, not making the plant susceptible to the naked eye, but over here you're causing a major problem that's actually bringing down the yield of your farm, the economic productivity. So this is why, just one example of why comparison sampling is important, and utilizing this in multiple different ways, deep soil and shallow soil, right? Multiple different extraction methods, multiple different fields, looking at different one cultivar to another. So the comparison sampling doesn't stop at the individual test. And that's why we have a data portal on the site where you can chart and graph one sample's nutrient values next to another sample's nutrient values for comparison. So this is just another layer of data to compare, okay, we have a really strong crop over here. This is the best we've ever done. Carbon is king. Thanks again very much, and look forward to seeing you all next week. Take care.